In this video, I'm talking to you about 2022 Paper 1 Question 8. And essentially it's all about a trig graph. We're given a trig function, h of t equals 72 minus 60 cos pi over 3 times t. And for the first part of the question, we simply have to sub in values for t and come up with the corresponding h of t. Now, a common mistake students might make here is to have their calculator in degrees. You should recognize that the angle is pi over 3t. We're told that the angle is in radians. And because the angle is in radians, you need to put your calculator in radians. If you put your calculator into radians and you sub in a 0 for t, you get 12. And then you just sub in 1, 2, 3, 4, 5, 6, 7, 8, and you should get these corresponding values each time you sub in. So part B is quite straightforward once you have the correct coordinates in part A. All I've done here is plotted my 8 points, and we can see we have that cost graph. Remember, this is a negative cost graph, so it starts at the minimum point, goes up to the maximum and back down to the minimum. We can clearly see from the graph that the period is 6 because it starts at the bottom, goes up to the top and back down to the bottom after when t is equal to 6. Furthermore, remember that the 72 represents the midline. So the midline of this curve is simply 72. And that the amplitude is the coefficient of cos. In other words, if my midline is 72, the maximum is 72 plus 60, the minimum is 72 minus 60. And remember, we don't actually need the plot in order to identify the period. The pi over 3 here would indicate what the period is. Remember that we've learned that the period of one of these trig graphs is 2 pi divided by c, or in other words 2 pi divided by the coefficient of t. So the period would be 2 pi divided by pi over 3. And if you plug that into your calculator, your period simply works out as 6. We can see it on the graph once we have our graph accurately, but we actually could have just derived it from h of t itself. So for part C, we just have to fill those in. Whereas for the period you can clearly see on the graph is just 6 minutes, or 2 pi divided by pi over 3, it just gives us 6 minutes. The range is the minimum to the maximum. The minimum value is 12 meters and the maximum value is 132 meters. So that's all you need for part C there. Okay, in part D, we're asked to work out what is the maximum length of time that we could spend more than 42 meters above the ground if we were on this Ferris wheel for 50 minutes. So what I've done, it's very hard to understand this without a good sketch. So I've sketched our trig graph here. 72 represents the midline, so the average height you are above the ground is 72 meters. 60 represents the amplitude, so that means you go up 60 to 132, down 60 to a minimum of 12. And we know that the period is 6 minutes. So I know that if this is my starting point, it's a negative cost graph, so I start at the minimum, go up to the maximum, back down to the minimum after 6 minutes. Go up to the maximum, back down to the minimum after 12 minutes, same thing again after 18 minutes. Basically, the height above the ground, it oscillates and repeats itself every 6 minutes. We know from the first part of the question that after 1 minute, you're 42 meters above the ground. So you start at 12 meters above the ground and it takes 1 minute to get 42 meters above the ground. Then you go up to the top and back down, and after 5 minutes, you're also 42 meters above the ground. So let's just look at one full oscillation where you start at the minimum, go up to the maximum and back down to the minimum. If you started at the minimum, after 1 minute, you're at 42 meters, and then for the next 4 minutes, you're more than 42 meters above the ground. So from the first to the 5th minute, you're more than 42 meters above the ground. Then you go down and you spend 2 minutes, from minute 5 to minute 7, you're less than 42 meters above the ground. Then you spend another 4 minutes, more than 42 meters above the ground, and that repeats itself again and again. So the first thing we have to figure out is, in a 50-minute period, how many full oscillations are we gonna go through here? And obviously the largest number that's divisible by 6 to closest to 50 is 48. 48 divided by 6 simply gives me 8. That tells me that in a 48-minute period, I do 8 full oscillations from here, from the minimum to the maximum to the minimum. In other words, every oscillation is 4 minutes, more than 42 meters above the ground. If I do 8 full oscillations, then the amount of time that I would spend more than 42 meters above the ground is 32 minutes. But you have to be careful here. Obviously, if I want to maximize the length of time that I spend 42 meters above the ground in a given 50-minute period, I want to start here. This is the ideal point for me to start. If I started here, then that means for the first 4 minutes, I'm above it, then I spend 2 minutes below, then 4 minutes above, and then 2 minutes below, and I do that 8 times. So after 48 minutes, I've spent 32 meters above the ground. And just imagine now, if I went up and down 8 times, if you started at this point, after 8 full oscillations, you would end up at a similar point. You'd end up about to go up again. So imagine there could actually be 8 full up and downs between this point and this point. I just can't fit it on the diagram. But that would represent 32 minutes above the ground. Then I would spend 2 more minutes. This could represent minute 48. Then minute 49 I might be up here, and minute 50 I'd be up here. So that tells me I could do 8 full oscillations, which represents 32 minutes, and then I could spend the final 2 minutes 42 meters above the ground. So to get the final answer, it's 32 minutes plus 2 minutes. So the maximum amount of time that you could spend more than 42 meters above the ground in a 50-minute period is 34 minutes. And that's your final answer for part D. Okay, in part E, we need to work out the second time that the point A is 110 meters above the ground. So obviously this is a trig graph, and there's an infinite number of times where the point A will actually be at 110. We're looking for the second one. So you're just initially given an equation, and your goal needs to be to isolate the cos of the angle. We're trying to isolate the trigonometry first of all. So the first thing I did was subtract 72 from both sides, and the 72 is gone from the left. 110 minus 72 is 38. Then I divided both sides by minus 60, because obviously I want to get the cos, the trigonometry on its own. So the right hand side becomes 38 over minus 60, which is simplified to minus 19 over 30. So the cos of the angle is equal to minus 19 over 30. And there are an infinite number of answers. We want the second one. So you have to realize that we're now on a unit circle question, and this is messy enough to work out. First of all, it's in radians, so that means anything you do with your calculator from here on out has to be in radians. Remember, in this case, the cos of the angle is negative. So we have to consider what quadrants are relevant here. Think of your A, S, T, C. Cos is negative in the second quadrant and in the third quadrant. So the first answer will be the one in the second quadrant. The second answer will be the one in the third quadrant. The second answer, the second solution to this is the one that I want. I want the second time that the point A is 110 meters above the ground. So completely just think about trigonometry here. The first thing we always do is we get our reference angle. Now remember, when getting your reference angle, we ignore the negative. I don't care that that's a minus 19 over 30, just treat it as if it's 19 over 30. So to get your reference angle here, you simply plug into your calculator cos inverse of 19 over 30. That will give you your reference angle. And remember, your calculator needs to be in radians. If you plug this into your calculator, you get 0.8849. This is your reference angle in radians, and this would allow me to get angles in whatever quadrants I want. Obviously, I want the value in the third quadrant, because that's the second solution to this question. Remember, if we're dealing with radians, you start off at 0, and after a half of revolution, you're at 180 degrees, which is equivalent to 1 pi radians. So if I want a value in the third quadrant, you start off at pi and you go into the third quadrant. In other words, to get your answer here in the third quadrant, it's equal to pi plus the reference angle, which is 0.8849. Now let's plug that into our calculator. Now if you plug that into your calculator, pi plus your reference angle gives you 4.026536 radians. But now don't forget that what we're after doing is working out a value for pi over 3 times t. I don't want a value for pi over 3 times t, I want a value for t. So to finish this off, we have to do just a little bit of algebra. We're after solving. The answer is pi over 3 times t equals 4.026536. And if we solve this to find t, we'll get our final answer. Obviously, the easiest thing to do here is to get t on its own, you simply divide both sides by pi over 3. So all we're going to do is plug that into our calculator. 4.026536 divided by pi over 3, that will give me a value for t. So if you plug this into your calculator, this value divided by pi over 3, you get your final answer. T is equal to 3.85 minutes. So that's the solution. That's the second time that the point A is 110 meters above the ground. In part F, you're asked to find the average height that you are above the ground over the first 8 minutes. Now you should recognize that this is our average value formula that we studied in integration. The average value formula is 1 over b minus a. We integrate from b to a, whatever the function is. So in this, the b and the a are the limits, and in this case the limits are from 0 minutes to 8 minutes. So 1 over b minus a is 1 over 8 minus 0, and then our limits will be from 8 to 0. And what we need to do is integrate the height function. And if I do that, if I work this out, that will tell me the average height that you are above the ground over the first 8 minutes. So obviously this fraction just simplifies down to 1/8. If you integrate 72, it becomes a 72t. This term might cause a little bit more bother. So the minus 60, you just take down the minus 60. The coefficient is not going to affect the question. But if you look at your integration page in your log tables, it tells you that the cos of an angle becomes the sine of that angle. So cos pi over 3t becomes sine pi over 3t. But don't forget that you have to divide by the derivative of the angle. The derivative of pi over 3t is simply pi over 3. So cos of an angle becomes sine of that angle, but then you divide by the derivative of the angle, so we divide by pi over 3. Once we've done that, the rest of this is relatively straightforward. All we have to do is sub in our limits. I'm going to sub in 8 first, then subtract and sub in 0, and we'll work out our final value. So in order to sub in our limits, the first thing we do is we take our 8. Everywhere there's a t, you sub in 8. And then there's a minus between them, and then you take your 0, and everywhere there's a t, you sub in a 0. Now, what I did first was I took all of this and plugged it into my calculator. Again, your calculator has to be in radians, and you get 526.38. If you sub all of this into your calculator, you simply get 0. So I'm left with 1/8 times this value, and my final answer, the average height you would be above the ground over the 8 minutes is 65.8 meters.